Hey Math 1, got a new lesson for you. It's still about solving equations, but I'm adding in here this component of being able to write them. So today I've got 4 examples to show you. You have 6 problems to exercise your way through this. It's going to be very focused on proportional equations in which you're basically saying, hey, if I have x over 5, and I know that it's the same as 6 over 11, say, I can find that x using my knowledge of how to solve equations where you're finding common denominators. So, without further ado, let's talk about our first one. In an alternate reality, Rolling Stone magazine offers its writers $2,600 for 1,500-word articles on an average. If the brilliant Carl York writes a 4,000-word article entitled "The Benefits of Rocking Out," or "The Benefits of Running Whilst Rocking Out," and Rolling Stone agrees to pay him a per-word average of their 1,500-word contracts, how much will he get paid? So that was kind of a wordy thing, but keep in mind, they're basically saying, Rolling Stone is saying, hey, we'll give you whatever $2,600 divided by 1,500 words averages out to be based on 4,000 words. So they're saying, hey, $2,600 per 1,500 words. How much are we going to pay you? We're going to pay you an unknown amount of dollars per 4,000 words. And that's kind of how the proportion works. So I'm going to kind of take away, notice that I have dollars over words equals dollars over words. I just need to make sure that that connection is consistent on both the left and right hand side of that equation. So I'm going to get rid of the dollars and the words to try to just solve it with the numbers themselves. So 2,600 over 1,500 is equal to, let's just make this unknown x over 4,000. Now, before I do anything, I notice that these both have double zeros at the end, which technically I can simplify this fraction by saying divide the top by 10 and divide the bottom by 10. Now it's 260 over 150. Do it again. Divide the top by 10 and the bottom by 10. You're left with 26 over 15. Yeah, so this just eases the burden of our calculations. Now, before, when we solve those equations that were just given to us, I always said, let's just find a common denominator and then we can ditch them. There's an alternate way to solve these things, though, when they look like a fraction equals a fraction. And here it is. If I wanted to find common denominators between 15 and 4,000, I can always just multiply by the other denominator if I don't want to take the time to actually think through it. Like I could count by multiples of 4,000 and try to divide 15. Or I could just say, what if I multiplied this one times 4,000 and this one times 15? Aren't these the same denominators? They are. So if you multiply the left one by 4,000, you'd get 26 times 4,000. If you multiply the right by 15, then you multiply the top by 15. Notice, I took this times the x, and I took this times the 26. It's almost like I cross-multiplied. I took 15 times x, and that's going to give me 15x over here. I took 4,000 times 26, and it gets me whatever 4,000 times 26 is. Notice, if the denominators are identical, you can ditch them. Okay, so cross multiplication. That's a shortcut for solving very simple proportions in which all you have is one fraction on the left and one fraction on the right. Okay, so now we can solve this. You know what? I'm just gonna divide by 15 right here, and think of it like this. No. Hold on. I don't want to overcomplicate things. Let's not overcomplicate. So 15x is equal to, here's what I'm going to do. I'm going to take 26 times 4 and then add 3 zeros. So it should be 104. That confirms it. So it's 104,000. And I'm dividing that by 15. So we're talking about money. I'm going to clear out this side here a little bit. I'm going to put the 104,000 inside the box. Remember, my decimal's right here. And I'm going to put the 15 on the outside. 15 goes into 10 0 times, so I got to go out to the 4. 15 goes into 104. Let's see, 15. I think 105 is almost... What's 105 divided by 30? 15. I think it's 7. Yeah, it's almost 7. Not quite, though. It's a 6. Because it didn't quite get to 105. So 6 times 15 is 90. So I'd subtract that. It'd be 14. Drop a 0. That's got to be 9 times. All right. 150 would be 10. So it's 6,900. Let's see. 9 times 15 is 135. So then you'd subtract them. It's 5. Drop a 0. 15 goes into 50 3 times. 45. And I got 50 again. So it's another 3. And it's just going to keep being 3s all throughout. So it's 3, 3, 3, 3, 3, 3, 3. All right, so I made that one kind of a challenging calculation. Here's the deal. Make sure you process this like you know exactly what you're talking about. We're talking about a question mark of dollars. This dollar amount is here. Okay, what are they going to pay Carl? Carl's going to get paid $6,933.33 if that's their exact agreement. If it's going to be based on their per word average of the $2,600 for a 1,500 word document, that's how much he can get paid. All right. I think that was the most complex of these. These other ones shouldn't be so hard. Here's number 2. So now that you've got the gist of it and you know a kind of a shortcut to move through, things should be much easier. All right, so I create a Beast Treat smoothie that blends bananas, strawberries, kiwis, blueberries, raspberries, and avocado. Delicious. If 1.5 gallons of smoothie requires 15 Sun Gold kiwis, let's just be honest, they're the most delicious of all the fuzzy fruits. Determine how many kiwis are needed to create 12.5 gallons of smoothie. So we're going to ship it off to a big group of people because they love it so much. So how do we do this? Well, it looks like what we're trying to do is determine how many kiwis are needed. And we know that there's the gallons of smoothie that is kind of like the other part to this ratio. So here's what I'm going to do. I'm going to say right away that I'm going to create a proportion that has kiwis over gallons on the left-hand side, and then that must equal. So for the little mix, the 1.5 gallons, that's maybe the left-hand side, and then the right-hand side is the big amount of kiwis over the big amount of smoothies. So small scale kiwi to smoothie, big scale kiwi to smoothie. So it looks like 1.5 gallons of smoothie, so 1.5 gallons on the bottom. I guess I could do 1.5 or make it 3 halves. Is 15 Sun Gold kiwis, so 15 kiwis on top. On the right-hand side, we're creating 12.5 gallons. We don't know how many kiwis. That's the question mark. So the proportion we're solving is 15 divided by 1.5 is equal to x kiwis over 12.5. So you've got a couple options here. If you want to, you can just cross multiply and get moving on the problem. I actually see something right away though. I don't know if you guys notice it, but 15 divided by 1.5, they're basically the same digits. The decimal point's in the wrong spot, kind of. So here's what we can do. We can rewrite 15 over 1.5 and say, this is the same as 150 divided by 15. Why? Because I can multiply the top and bottom by 10 and create a fraction that still has the same value. Right? 15 kiwis per 1.5 gallons is the same as 150 kiwis per 15 gallons. So what's 150 divided by 15? It's 10. 10 times 15 is 150. So I'm going to rewrite this as 10 kiwis per 1 gallon is the same as x over 12.5. And that's super helpful because if you do the cross multiplication, I've got 1x already. That's the thing we're always solving for, a 1 in front of the x. And it equals some decimal times a power of 10. What happens when you multiply a decimal times a power of 10? It moves the decimal to the right one spot. Okay, so we need 125 kiwis. And that's our final answer. 125 delicious kiwis. All right, here's another one. At Spring Ridge High School, 5 out of 12 students are involved in band or chorus. If there are 600 students at SRHS, how many are not involved in band or chorus? All right, that's interesting. They told us how many are, and then they want to know how many are not. So this is one of those situations where it's like, here's the band slash chorus divided by the total, yeah. So divided by the little group that they have. So we know we have 5 band or chorus students in a group of 12 total. But then we're like, what's the big total? There's 600 students at the high school. How many are not? Well, I guess I could just find how many are and then subtract it from 600. Or wait, can we just change this right here? 5 out of 12 are band or chorus. So how many are not? 7 out of 12. Yeah, so why don't we just change this 5 to a 7? And this will give us how many are not band and chorus. And then this will be the question mark of total band and chorus. or total not band and chorus. So 7 over 12 is equal to x over 600. And this will get us to our answer right away. So I can't reduce 7 over 12. I can multiply 600 times 7. And then I'd set that equal to 12 times x. So 7 times 6 is 42, with 2 zeros after it. And that equals 12x. Divide by 12. Put the 42 in the box. If they're both even, we can simplify what we can do in our head. What I mean by that is cut 4,200 in half. Cut 12 in half. And we can keep moving if we want to. They're both even still. This would be, half of that's 1,000. Half of 100 is 50. 1,050. Half of 6 is 3. All right, I can take 1,050 divided by 3. Three goes into 10 3 times. Gives us 15. 5. 15. 0, 0. All right. Sorry, it's a little bit tough to see this here, but 1,050 divided by 3 is 350. So x is equal to 350. 350 students are not in band or chorus. So that was kind of tricky because I gave you information about how many are, and then you had to kind of convert it to how many are not. All right, sorry this video is going a little longer than I intended, but I'm just going to keep moving until we get this thing done. All right, so we got a guy named Mr. Roman, and he's looking to improve his quadriceps strength, which means doing a lot of lunges, okay? So he's managed to average 20 lunges every 50 feet in the initial stages of his training. I was able to procure enough plutonium, legally, to power up my time machine, and I traveled a year into the future. I discovered that he's now developed an indestructible leg strength through a rigorous routine of 600 yards of lunges. Wow. So he's still managing to do 20 lunges every 50 feet. He's just doing a ton more than he did at the beginning. He's doing it for 600 yards. So how many lunges is future Mr. Roman completing at this point? Well, let's think about this in terms of, I'm given a lunges divided by feet ratio to begin with. So let's just look at it from that perspective. So at the beginning, he was doing a little lunge amount divided by a little distance amount. Now we got to figure out big lunge divided by big distance, big feet. So 20 lunges every 50 feet. How many lunges, that's the question, after 600 yards. So we have to convert yards to feet. So it's usually common knowledge, all right, that there are 3 feet in 1 yard. So for every yard, I'm just going to times by 3, multiply by 3. So what's 600 yards times 3 feet? Well, 6 times 3 is 18, but double 0. Okay, so we're talking 1,800 feet here. All right, so I'm going to rewrite this off to the side. And I can simplify 20 over 50. Divide the top by 10 and the bottom by 10, and it's 2/5. Nothing else to simplify, so now I'm going to cross multiply. 2 times 1800, that's set equal to 5 times x. Double 18 is 3600 with the 2 zeros equals 5x. And then I'm going to divide by 5. So check out the division. You can put the 3600 in the box, the 5 on the outside. 5 goes into 36 7 times. Multiply that, subtract, you get 10, 2, everything zeroes out, but you still got one more digit to take care of. It's 720. So what did we just solve for? X equals 720. The question mark was lunges. He can do 720 lunges. All right, Mr. Roman, use that lunge power wisely. All right. Thanks, guys, for watching. I know that was kind of goofy because I had some weird examples in there, but hopefully this makes sense, the ideas of how we set up proportions, that, we're just using our common knowledge of how to get x by itself when we're given fractions. Thanks for watching.